3.1 Extrema on an interval. Things to know. A closed interval has brackets, an open interval has parentheses, and a half-closed interval has one bracket and one parenthesis. A closed interval has a dark filled-in circle, and an open interval has an open circle. There's no color inside of it. A relative or local extrema is a point that is a maximum or minimum relative to the points around it on both sides. A point that is a maximum or minimum when looking at the whole function is an absolute extrema. Theorem 3.1. If f is continuous on a closed interval ab, then f has both a minimum and a maximum on the interval. Here you can see a relative maximum and a relative minimum, and another thing to remember is when there's an open circle, there is no relative minimum or maximum as shown in the graph. Here we can see that a relative minimum is concave up and a relative maximum is concave down. Also, we can see local maximums versus global maximums. A critical number is an x value where the derivative is either 0 or undefined. On the graphs below, the one to the left is undefined and the one to the right is 0. Relative extrema must occur at a critical number, but every critical number is not necessarily a relative extrema. How to find extrema on a closed interval. Step 1. Find the critical numbers of f in AB. Step 2. Evaluate f at each critical number in AB. Step 3. Evaluate f at each endpoint of AB. Step 4. Least of these values is the minimum, greatest is the max. Example number 1. Find the extrema of the function 3x to the fourth minus 4x to the third. Differentiate the function to get 12x to the third minus 12x squared. Then set that to 0. Next, find your critical numbers 1 and 0, because 1 minus 1 is 0, and 0 squared times 12 equals 0. Finally, evaluate at each endpoint and critical number into the original function, 3x to the fourth minus 4x to the third, to get f of negative 1 equals 7, f of 2 equals 16, f of 1 equals negative 1, and f of 0 equals 0. The most positive number, 16, is the maximum, and the most negative number, negative 1, is the minimum. Example 2. Find the extrema of the function 2 sine x minus cosine 2x on the interval 0 to pi. First, differentiate. 2 cosine x plus 2 sine 2x. Then set this to 0. Since this includes some trig, there is an identity sine 2x equals 2 cosine x sine x, which you plug in to get 2 cosine x plus 4 cosine x sine x equals 0. The next step is to factor to get 2 cosine x times 1 plus sine x equals 0. Then we find our critical numbers where x equals 0. Pi divided by 2 and 3 pi divided by 2 are for cosine x to be equal to 0. Then 7 pi divided by 6 and 11 pi divided by 6 make the 1 plus sine x equal 0. Finally, we evaluate at each endpoint and critical number. F of 0 is equal to negative 1, f of 2 pi is equal to negative 1, f of pi divided by 2 is equal to 3, f of 7 pi divided by 6 is equal to negative 3 divided by 2, f of 11 pi divided by 6 is equal to negative 3 divided by 2. In this example, we have 1 maximum and 2 minimums.
Created using Powtoon.